to the negative absolute value of x, from negative infinity to positive infinity. Here's our integral. First, let's visualize what this function looks like. Here's our coordinate system. And here's the graph of e to the negative absolute value of x. To solve this integral, we need to split it into two parts because of the absolute value function. We'll split the integral at x equals 0, where the absolute value function changes its behavior. For x less than or equal to 0, the absolute value of x equals negative x. This means on the left side, our function is e to the x. For x greater than or equal to 0, the absolute value of x equals x. So on the right side, our function is e to the negative x. Therefore, we can rewrite our split integral as the integral from negative infinity to 0 of e to the x plus the integral from 0 to infinity of e to the negative x. Let's evaluate the first integral. The integral of e to the x is e to the x plus c. When we evaluate from negative infinity to 0, we get 1 minus 0, which equals 1. Now for the second integral, the integral of e to the negative x is negative e to the negative x plus c. When we evaluate from 0 to infinity, we get 0 minus negative 1, which equals 1. Finally, we add our results together. 1 plus 1 equals 2. This represents the total area under the curve of e to the negative absolute value of x. Therefore, the integral of e to the negative absolute value of x from negative infinity to infinity equals 2